is part 2 of basic chemistry concepts for grades 11, 12, LS, and GS. The table of advance or progress. The table of progress of a chemical reaction is a chemical tool used to describe the composition of a chemical system during its transformation. The advancement is noted X and it is expressed in mole. It corresponds to the amount of a product that would form with a stoichiometric coefficient 1. So the amount of which would be transformed with a stoichiometric coefficient 1. The advancement X is 0 at the beginning of the reaction, and it increases during the progress of a reaction to reach a maximum value. When the reaction is over, this means ended, the total consumption of one of the reactants occurs. The numbers that precede the advancement X are always the stoichiometric coefficients of the balanced equation, and the equation must be balanced in advance, preceded by a sign negative for reactants to indicate a decrease, and a sign plus for products to indicate an increase. X is greater than 0, so the system evolves in the forward direction. For example, CH4 plus 2O2 gives CO2 plus 2H2O. If X represents the number of moles of CO2, it is a product, formed at an instant T, then the number of moles of H2O formed is actually 2X in moles. The number of moles of CH4 consumed because it is a reactant, is X. The number of moles of O2 consumed is 2X. A complete or total reaction is given by the following equation. 4Al plus 3O2 gives 2Al2O3. This reaction can be described by a progress table that will represent the evolution of the system with time. Initial state at time equals 0, intermediate state at time greater than 0, and a final state at any time greater than 0 or at the end of the reaction. The same equation above is represented in a table. I assume to begin with 16 moles of Al and 9 moles of O2. Actually, this given is at time equals 0, where there is no of Al2O3 is brought to the mixture. Al2O3 at time equals 0 is not formed yet. That's why we put 0. Now the intermediate state at time greater than 0, this means when the reaction begins, 16 minus 4x at any time t, 9 minus 3x at any time t, and 2x at any time t. Actually, the initial minus the advancement or the reacted. 16, it is the initial, minus because it decreases. 4x, it is x preceded by the stoichiometric coefficient 4, preceding the Al. Also, 9 minus 3x, 9 is the initial number of moles, minus is a sign that indicates a decrease, and x is the advancement multiplied by 3, which is the stoichiometric coefficient of O2. And plus 2x, actually it is 0, the initial of Al2O3, plus 2x, and 0 plus 2x is simply 2x. At final time, or at time equal infinity, you have to add the index max after x. Observe the second line and the third line. 16 minus 4x below is 16 minus 4x max. 9 minus 3x below is 9 minus 3x max, and finally 2x max instead of 2x. Determining the value of maximum advancement and the limiting reactant. X max is actually represents the mole ratio of a reactant. Assumption 1 for the same previous equation, if and if is an assumption. If Al is the limiting reactant, then there will be no more moles at the end, which means that the 16 minus 4x max is equal to 0, hence x max is equal to 4. Assumption 2, if O2 is the limiting reactant, then there will be no more at the end, which means that 9 minus 3x max equal to 0. Consequently, x max equal 3. I said x max is a mole ratio. We compare the mole ratio to decide the limiting reactant. We take the smallest value of x max to indicate the limiting reactant, since it is a mole ratio. The smallest mole ratio indicates the limiting reactant. Here in this case, x max equal 3 of oxygen, then oxygen O2 is the limiting reactant, while Al is an excess reactant. A very important note, if the two values of x max of Al and that of O2 are equal, in this case, we say the initial mixture is stoichiometric. Determining the molar composition of the system in the final state. According to the progress table indicated before, we have to substitute x max of the limiting reactant. Number of moles of Al remained equals 16 minus 4x equals 16 minus 4 times 3 equal 4 moles. This reactant was in excess. Number of moles of Al2O3 formed is 2x max. 2 times 3 equals 6 moles. This is the maximum formed moles of the product. Number of moles of O2 remained is equal to 0. Why is equal to 0? Because oxygen O2 is the limiting reactant. Thank you for your attention. See you.